Hi students, welcome to chemistry online classes. In the previous classes, I explained about the nomenclature of alcohol, phenols and ether. Today we will discuss about the structure of alcohol, phenol and ethers. For example, the basic alcohol I am taking here, that is a CH3OH. H. This is called methyl alcohol. Another one is here phenol, that is also basic phenol I am taking here. Double bond, single bond, double bond, double bond. Here OH. Next ether. H. This is ether. At every oxygen we have the two lone pairs of electron. This is also lone pair of electron, lone pair of electron, lone pair of electron, lone pair of electron. It means there is pair electron. Now, this oxygen having which hybridization? You may be knowing the first year chemical bonding chapter BSPR theory and hybridization, next molecular orbital theory. In that, how to identify hybridization you may be know in hybridization part, and according to BSPR theory also we can tell two pairs of electron. Two pairs of electron, P as a pair of electron. Two pairs of electron, that is sp hybridization. Three pairs of electron, that is nothing but sp2 hybridization. Four pairs of electron, that is sp3 hybridization. Now, around this oxygen, one bond with one pair of electron. This bond formed by the one pair of electron. Okay? So here one pair, two pair, this is also third pair, this is fourth pair. So four pair of electron means this is sp3 hybridization. So in every molecule 1, 2, 3, this oxygen having sp3 hybridization. Here also sp3 hybridization. Here also sp3 hybridization. Because around this oxygen molecule 4 pairs of electron. Then you may be confused here. This pair of electron, bond pair or lone pair, everyone, all included here. Don't get only bond pair. Any pair of electron that is considering this hybridization. So now, you may be knowing the chemical bonding chapter, sp3 hybridization means, for example, this carbon having the sp3 hybridization considered, for example. Then what is the bond angle? 109.28 degree. This is the bond angle between any two bonds in this, for example, methane. Okay? If it is in methane, every bond angle is 109.28 degree. Then here also we are expecting how much? 109.28. But you know that in first year only, water molecule, here also pair of electron, here also pair of electron. Here also oxygen hybrid means sp3 hybridization. But water molecule, what is the bond angle? You may be know that 104.5 degree. This is standing already very important for P also and competitive exam also. Why this bond angle is 104.5? Actually we are sp3 what we are expecting 109.28, but it is decreased from 109 to 104. Reason, lone pair repulsion. Electron having negative charge, negative repel, positive also repel, negative will attract. You may be knowing in physics, unlike charges are attract, like charges are repel. So now, this pair of electron having a repulsion. When these are repelled together, if you want to write like this is a pair of electron, this is a pair of electron. In between this is repulsion. So that this bond, lone pair of electron and this bond pair of electron again will repel. So when it repel, this comes to this position. Then what happened here? Before that some angle is there. This extra part is now not there. It means bond angle what happened? Decrease. Understand the concept? Here also, this bond pair of electron and lone pair of electron are being repelled. When it is repelled, it comes to this position. So actually, before here is there, now both sides some angle is decreased. When angle is decreased, it comes from 104 to 109 to 104. Due to lone pair repulsion, lone pair repulsion also is there. Lone pair bond pair repulsion also is there in water molecules. Similarly, the same concept we have to utilize here. Here also, lone pairs are there and bond pairs are there. Due to this lone pair bond pair repulsion and lone pair repulsion, here bond angle is 108.9. Here how much is there? 109 is there. Nearly 1 degree or something it decrease. It means due to lone pair and bond pair repulsion and lone pair repulsion. Here nearly 109 degree. But this small amount is decreased here. Here nearly 109 here 108.9 here. But keep in mind, here bond angle is 111.7 degree. Then you may be expect the question, why here bond angle is increased? According to here, these two are decreased, but here is increased. Then this concept here applicable or not? Then here also applicable, but one more repulsion is there. This CSC is one bulky, this CSC is one bulky. Now consider this 1, 2, 3, another is bond, oxygen bond. Here also like this. So in between this repulsion takes place. When this repulsion takes place, again it goes away. When it goes away, bond angle what happened? Increase. When come near, it is decrease. So when due to repulsion of this steric hindrance, then bond angle what happened here? Increase. So this question one time asked in the competitive exam, what is the correct order of bond angle in alcohol, phenol and ether? So highest bond angle generally in ether due to the repulsion in the alkyl group. This is CH3 one alkyl group, CH3 is one alkyl group. So due to this repulsion in alkyl group, repulsion in alkyl group, this is called steric hindrance. It means space hindrance. Steric hindrance, space, there is no available for this two methyl group, that's why they go away from each other. Here also lone pair repulsion, lone pair bond pair repulsion, here also same method. But sometimes they will ask the question, this is also. Here also carbon oxygen bond is. This is nothing but carbon and also carbon oxygen bond is. Here also carbon oxygen bond is. Here also they will ask one question, what is the bond length between these carbon and oxygen? Here 142 picometer. Here 139 picometer. Here 141 picometer. Here nearly equal is there. Only small difference is there. Because this carbon oxygen bond here, it is single bond here. Here also single bond is there, but it may form resonance structure and it may go in double bond character. That's why it is decreased. This is 139 picometer. Because this lone pair may comes to here and this bond may comes to here, that time we get the double bond character. So due to this double bond character in between this carbon and oxygen, here bond length is decreased. So you have to carefully remember each and everything for competitive exam. Each exam there is no question like this. Maybe they may ask what is the bond angle in phenol, what is the bond angle in ether, what is the bond angle. I think this question may be asked in PhD also. What is the bond angle in ether? So triple 1.7. It means 111.7 degree. Okay, this is about the structure of alcohol, phenol, and ether. Now we will discuss about the preparation of alcohol, next phenols and ether. But in first discussion we will discuss both combined because these are OH group, alcohol group is there. Ether we will discuss separately. Okay. So now the first preparations. Preparation methods. First one, from alkene. You know that alkene is a double bond character. Don't know single bond, that is double bond. Okay. So those are having double bond, they are considered as alkene. And keep in mind, this is a very important question for PhD exam. In your total organic chemistry, 3 mechanisms are there. The 2 mechanisms in this alcohol phenol chapter and 1 more mechanism in carboxylic acid chapter. So in this total 3 mechanisms, one is compulsory question for PhD. 100% guarantee in these 3 mechanisms. Okay? So it is also having one mechanism in your textbook. For every reaction there is a mechanism, but in your textbook given 3 mechanisms. So that in that 3, one will be compulsory question for your PhD exam. That is 3 marks question generally. So now here given there is CH2 double bond CH2. This is called ethene. It's called ethene. This ethene react with the water in presence of acid. Otherwise, instead of this, sometimes may be represented as like this also. Don't confuse. Okay? 2 hydrogen plus 1 hydrogen, 1 oxygen, 1 oxygen. Due to the formation of coordination covalent bond, you will get the one positive charge. Like this also may be represented, or like this also may be represented. So totally consider now in this act as a catalyst area. This is nothing but H+. In this water molecule, it may be H as H plus and OH. One H added to left side carbon, OH added to right side carbon, because these are equivalent. Any one side added will get the same name. There is no different. H added to the right side, OH added to the left side also will get the same name, because ethanol you will get any one side added. How we have to add that? This is the mechanism. So generally CH2 already one H is added, this will be converted to CH3, and this bond will be breakdown, and one bond is left, and CH2, and this will be OH added to right side carbon. Then this is called ethanol. Ethanol. Okay. Now ethene in acidic medium react with the water, it gives the ethanol. This is a general reaction. Then how this reaction takes place? That is called its mechanism. Mechanism is the most important part. Once again I am telling you, keep it in mind. So first one is, you know that this acid H plus may be, which one will give acids? Because proton donors are known as acids, and which will give the OH when they are called as a base. So we know that, for example, consider maybe H2SO4 consider. This H2SO4, it breaks down into H plus and HSO4 minus. Okay? Now, water molecule. So in this water molecule, we have a lone pair of electron. This is vacant orbital. Because hydrogen atomic number is 1. Electronic configuration is 1s1. If you write that hydrogen 1s1, this electron is lost, then what we can write? When electron loss is plus and this is 0. It means in 1s orbital there is no electron. It means there is vacant orbital. Then this acts as an electrophile. Electrophile means what is it? Electron deficient. Electron deficient means they can take the electron from which will give. So here which will use? Oxygen will give the lone pair to this oxygen. Here vacant orbital, consider this box will give. Box is nothing but vacant orbital. Here 1s. Then we will get the here coordination covalent bond. Then this is represented as H3O plus. Simply it is represented like this H, O, H, H, and H. Okay. So this is the H3O plus. Now this H is came from which one? Acid. Remaining 2 hydrogens are belongs to which one? Water molecule. So this is one first step. Then second one is alkene. This alkene CH2. react with this H3O plus this is called hydronium ion. What do you call this? Hydronium ion. One more lone pair is one lone pair only last, another lone pair is present here. Okay. So now here this is pi bond is a sigma bond. First bond is sigma bond, second bond is which one? Pi bond. Pi bond act as a nucleophile, it means electron rich part. This electron rich part gives to the electron deficient part. So carefully observe here. Bond may be moved to the right side or bond may be moved to the left side. But keep in mind where it is going arrow mark there is a negative part, from where it is coming there is positive. Because this bond is there, this is a bond considered. Two electrons are. Here A is and here B is. If bond is moving like this, this is a electron, this is a B electron. This B is more electronic even is taking towards the B means this electron gone towards the B. So this electron belongs actually A. So taking electron, that's what is negative charge, it lost, that's what is positive charge. Okay? That's where arrow mark goes, that is a negative. From where it comes, that is a positive. Both are equivalent. CH2 is there. That's why any one side you can move this bond. There is no difference. Okay? So for example, if it is moved right side, it is negative, this is a positive. If it is moved, then it is negative, this is positive. But actually in books it is represented as like this. Okay? It means this pi bond, one side is converted into negative. This negative is given to this one. Negative positive, what is that? Bond form. This is for example bond moved to this carbon, it is negative. If it is moving, this is negative, this is positive. Negative positive, bond form. Here negative is there. This negative positive, neutral. Negative positive, neutral. You know that one positive, one negative, neutral. Okay? Then here also bond form and here neutral. Now, H, single bond. Here is a positive. It meaning this bond moved towards which one? Left side carbon, and it was a negative charge. Along with this, O and H, that is called H2O. This is the first step. This is nothing but carbocation formation. Otherwise, it is called protonation of alkene. Its name is known as protonation. Between proton added to the alkene. H plus is nothing but what you call proton. It is called protonation of alkene. This proton is added to alkene. This is called protonation of alkene. And here carbocation is formed. Which type of carbocation? This is primary carbocation and secondary carbocation and tertiary carbocation. Then first we have to decide that carbon bonded to the how many carbon. This carbon directly bonded to the one carbon. Then it is called primary carbon and it is known as primary carbocation. Primary carbocation. So this is also known as a RDS, rate determining step. RDS means what? Don't think it is a bomb. RDS means it is rate determining step. Generally, rate determining step is a slow step. Rate determining step is a slow step. This you will know in the chemical mechanics chapter, that is 4th chapter in physical chemistry. So that you will know very clearly what is RDS or slow step. Okay. Generally, formation of carbocation is the slow step. Now, this is carbocation is unstable. This is called reaction intermediate. You may be learning in the first year carbocation, carbanion, free radical, nitrines, carbenes, benzene, like this maybe. But up to these level you may learn these three: carbocation, carbanion, free radical. These are reaction intermediate. They will not take this long time. Immediately they convert into another forming product. So this carbocation is more stable product form. If carbocation is less stable, then less stable product is formed. So that's why Here formation of product, this alcohol formation is depends on this carbocation formation. More stable carbocation forming major product, less stable carbocation forming that is minor product. This is the first step considering the reaction. This is actually normal. This is the first step we will given in the textbook. So according to mine, this is first, this is second. Now third step. This carbocation as it is written here, H, 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 here carbocation, H and H. Along with this, what is that? Water molecule. Here lone pair is there, it is electron rich. Electron rich will act as a nucleophile. This nucleophile is electrophile. Nucleophile gives electron to which one? Electrophile. Then this is nucleophile attack. Second step, what you call nucleophile attack. What do you call the second third step? It is nucleophile attack. This is nucleophile, which is having electron rich. That is called nucleophile. Nucleophile attack to carbocation. This is electron deficient one. Then we will get here H, H, H. You can write anywhere this bond. I want to write down or up, anyone write, because this is planar. I will show here bond with the carbon and this hydrogen and hydrogen. This is one vacant orbital is due to positive charge. So this p orbital is having one is up, one is down. The nucleophile can attack up also, down also. For example, down attack consider or up attack, anyone can consider, no problem. Then I want to write here O and here H and now positive charge. Oxygen with the 3 bond positive charge attack. Oxygen with the 2 bonds, between 2 hydrogen charge, 2 bond and 2 bond. One more bond found, that is plus. Because this lone pair given to this loss of electron it is. Loss of electron is whatever positive charge. That's why here positive charge, one more lone pair is the lone pair as it is you can write. Now this is nucleophile attack. Next one, fourth step. In this fourth step, as it is, because this is PUC exam pattern I am writing it. Actually here only you can continue. But in your textbook, what is given, that I exactly written here for your better understanding. So here H, 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 and one hydrogen, second hydrogen, O and H. This is H and positive charge. This is okay. This is called deprotonation step. D means what? To remove. In chemistry or the organic chemistry, DE means what is called to remove. K means when D means what is that? In organic chemistry, to remove. Deprotonation. It means proton removal. This is. Now here, this is positive charge. If it is given like this, even proton loss, from where this goes, then it gets a positive, where it goes negative. It goes towards the oxygen, means negative, negative, positive, neutral. Then it will be converted to one H plus. So now, already here which is there? HSO4 minus is there. Otherwise, here water molecule used. One water molecule we cannot use. One drop means in this so many water molecules there. Because one mole means how much? 6 into 10 power 23 molecules. So in one drop so many molecules will be there. That's why we can write here H2O. This H2O takes this one. Then it will be converted into CH3, H, 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 and here also H, here also H, here both H, here lone pair 2. Because due to this negative charge, we will get the lone pair, already one lone pair is there. Now this H and this H2O totally converted into H3O plus and here one lone pair. Now keep in mind, this is can be represented as CH3, carbon and 3 hydrogen, CH3, single bond, and CH2 is CH2, OH is OH. See? Here also what is that? CH3, CH2, OH. This is a clear mechanism of ethylene converted into alcohol. So here HSO4 minus. Generally, may be studied in first year. Nucleophiles are having negative charge and also neutral also. Now, what are the molecule here act as nucleophile? Any charge is it? No. This neutral nucleophiles also is it? Negatively charged nucleophiles also is it? So, we are taking one test tube. In this test tube, what is it? Argon also is it? H2SO4 is it? Water is it? So, in H2SO4, water and argon, both are, all three takes place in this test tube only. Then you can ask a question here. Here, water molecule is nucleophile is it? HSO4 minus also nucleophile is it? But why here HSO4 minus not act as a nucleophile? I am asking the question for you. Then you have to find the answer of why here HSO4 minus is not attacked. Because in this H2 what is it? HSO4 minus also is it? And H2 also is it? Then if HSO4 minus is attacked, then what is the product? Different product will get. But here not attacked. That is the question I am asking why. It acts as a nucleophile or not. So whatever you studied in first year, negatively charged species are acting as a nucleophile, then that is the concept. If it is, then it is right or wrong. That is the question I am asking to you. Okay? So find the answer for that question. Next one. Here this is a symmetrical alkene. Because if you cut like this, right side CH2, left side CH2, there is no chain. If it is unsymmetrical, is it? CH3, CH, double bond, CH2. If you cut like this, right side CH2, left side CH, CH3, then it is unsymmetrical.